Hello, everyone. So we are here to talk about the elephant in the server room, the environmental footprint of AI. And I guess you know, but as models grow larger, so their footprint. And today we heard, for example, about Wall's model, generating video from text and with zooming capabilities that were science fiction 2 years ago. And I'm sure there's a lot of people in this room who is using powerful or innovative AI tool without imagining the environmental footprint they can generate. And to give you an idea, the electricity consumption of the data centers represents 1.5% of the global electricity demand. So it's huge, and there is a growth rate of 13% per year. And this growth rate is mainly due to AI. Because to do AI models, we need massive compute. And massive compute means massive footprint. And for a long time, this was a black box. You deploy a model, and you have no idea what it costs the planet. So today, we will break that black box open. So I'm Elise from Scalaway, and I'm working on the environmental footprint calculator, which is a tool to give data to our users about impact data to our users about the cloud product usage. And to discuss on this subject, I'm with Boris, Head of Sustainability at Salesforce. Hi, Boris. So you're working on something huge, the AI Energy Score. So can you tell us a bit more about it?
Yeah, definitely. Thanks so much for having me at this conference. I think it's, first of all, really important to have sustainability part of the message, not just at sustainability conferences, but as a part of the AI conferences. So this is really important. So I'm head of AI sustainability at Salesforce. I work on both reducing the environmental impact of AI within our products, but also realizing that we're interdependent on the wider AI ecosystem, and we need to actually drive the entire ecosystem towards sustainability. And so one of the things we realized early on is that this lack of transparency, the fact that a lot of AI models are a black box, that's a foundational blocker to us being able to take the right steps towards sustainability. So about a year ago at the AI Action Summit here in Paris, we launched with Hugging Face, Cohere, Carnegie Mellon University, a new standard for measuring and disclosing and working to drive down the environmental impact of AI called the AI Energy Score. And today, we're actually launching a second version of it. If you follow the link here, you'll be able to see it. It officially goes live in a few hours, but you guys get a preview. But the idea here is there wasn't really a standardized way to measure and then compare apples to apples the energy efficiency of different AI models. So imagine you have metrics for a vehicle, or here in France, when you get an apartment or a house, you have a very specific number that you see on the energy efficiency. This is establishing that very same type of metric. But unlike a house or a car, the swing in terms of the environmental impact of different AI models is massive. We're talking orders of magnitude. So having that transparency gives you insight into which models you really need, which tasks you really need the highest powered models for, or which ones you can actually use one that's orders of magnitude less impact.
And you just released a new version, so what's new in it?
Yeah, so this new version, over the past year, reasoning models have really taken off as kind of the current paradigm. And these behave really differently than kind of the traditional large language models. So when we launched in February, there weren't that many reasoning models yet, so we didn't have any benchmarks specific for those. And this time around, that was a big focus, and we actually had to make a lot of changes to accommodate reasoning models. So they're on there, as well as a number of other text generation models. And we want to continue evolving this benchmark. As you all see, every week there's a new model released, if not more often, and architectures will keep changing.
It's fascinating, and at Scalaway we did the exact mirror image of that, because we realized that even if we choose an efficient model, thanks to your score, and run it on an inefficient server or on a region powered by coal or on hardware that need a lot of resources for its manufacturing, the net result is still bad. And I think we can imagine that your score is about the theoretical efficiency of the engine, and the Scaleway environmental footprint calculator is about how much fuel you actually burn in the real world. So to truly achieve green AI, we need both the right engine, the right model, and the right car in the right place, so the right infrastructures. And I'm curious, and I'm sure there is engineer in the room that wants to know how it works. When you calculate the energy score of a model, what you're actually measuring?
Yeah, so there's so many different variables when you're inferencing an AI model that impact its energy use dramatically. Everything from the specific GPU that's being used, everything from the various configurations, the batch size is a big one, the data precision. So all of these things dramatically change the energy profile of even within one model. So what we did, we tried to keep everything constant across the different evaluations, including the queries that we're sending. So we have very specific data sets of 1,000 queries per task. So we have a text generation task, image generation, and so forth. And so what we're doing is we're running the same exact queries in the same exact way, and then measuring the energy using a package known as Code Carbon, which actually taps into NVIDIA SMI, so the underlying energy utility of the GPU. And the only thing we're switching out is the model, so we can know for sure that we're comparing apples to apples. And yeah, it's a great point. It's not meant to be representative of a full deployment scenario. This is meant to be a comparable metric. And so you can use this to understand the differences between the models. And then when you're deployed, you can use something like Scaleway's approach to actually track what the impact is over time. Because all of those other configurations that you can alter, will make significant changes.
No, it's interesting. You provide very accurate and comprehensive data, and once again, our tools are complementary. And at Scaleway, we just relate the environmental impact of GPU instances. And so now we can tackle the full lifecycle assessment of an AI models. So our users, through the Scaleway console or through API, can get data about their usage of GPU instances and all other instances, actually. And this data take into account the hardware manufacturing, the transport to our data centers, the usage, I mean the electricity use, and the end of life. By end of life, I mean at Scaleway, all the hardware is refurbished or recycled, but it still have an impact that have to be taken into account. And we also take into account all the tools that makes our product works, so all the servers and storage device that we use internally to create products, and also data center manufacturing, and all the tools in the data center, like the cooling system, for example, and also the network. To create cloud product, we need network equipment that being manufactured, transported, and will be recycled. And last but not least, the impact of employees. So we work on a building, we travel, we work on computer, and all of this have an impact and is taken into account in the environmental footprint calculator. So our mission was to measure the environmental impact of cloud infrastructures and export this data directly to our users. And the goal is to provide as much as possible accurate and comprehensive data to the infrastructure level, and your tool providing it as a software level. So the two tools are complementary to get the environmental impact of an AI model. But we have to be honest with the audience. What are the current limits? Did you easily get all the data you need to make your calculation?
Yeah, so one of the North Stars of this project was to enable not just open source models to be analyzed, but also have a way for the closed proprietary models to be benchmarked in a secure way. So we launched it with a Docker container of the same exact benchmarking setup that folks could run in their own environment and just upload the logs. We did that ourselves at Salesforce, and we actually integrated the benchmarking into our own model card generation packages internally to kind of automate the environmental data portion of that. However, we've been talking to a lot of the closed model providers. They have not yet disclosed along this standard. Since February, there have been a few disclosures. So there was a Gemini technical report. Mistral also released a blog. Sam Altman posted in one of his blogs like a sentence about energy use. So since then, there have been a few different releases of this type of data, but actually none of them state the methodology in a deep way. None of them are comparable because you don't really understand all of those things that I mentioned earlier, the configurations, the batching, all of this stuff. And none of them are therefore as useful as they can be. So we do hope one day that there can be disclosures, the way that have already happened, but they can also be kind of released with something more comparable and standardized, like this project, or something different. We don't really care as long as it's standardized and transparent. So today it's primarily open weights models. That definitely limits its usefulness. If you're there, thinking about GPT-5, how does that compare to a Qwen model? We're not going to have GPT-5 there because that's limited by OpenAI's desire to disclose. But we do hope now that it's gaining momentum, that the customers of these proprietary AI labs will start demanding this information, because especially enterprise customers, when they're procuring these models and they're procuring them as a black box, there's actually a significant liability. And there's environmental regulations that are coming, and these models are part of these companies' carbon footprint, their scope 3 emissions, what it's called. And right now, not being able to fully understand them is a liability. So we've talked to a lot of big companies that are really starting to push these labs in the direction of transparency, and we hope that this can be a tool in that mission.
Yeah, I totally understand. The lack of standard format is a blocker for us too, and also the lack of information about the scope 3, so the manufacturing of the hardware. It was very difficult to get because the manufacturers are not always fully transparent about their environmental impacts. So we base ourselves on Boa Vista database, which is an association that works for sustainable digital technology, and they made a huge work to estimate the environmental impact of hardware manufacturing. And just a few time ago, they just get the impact of the GPUs, allowing us to add the GPU instances into our calculator. And now let's be practical. I'm sure there is a lot of ML engineers, CTOs in the room. So beyond the theory, what can they do tomorrow morning to effectively reduce their environmental impact?
Yeah, I think one of the first things is to be that voice calling for transparency. If you're a customer from one of the proprietary AI labs, you can add in language through your RFP process, and then actually within your contractual negotiations to ask for environmental transparency. And just know that you'll be joining a chorus of companies that are starting to demand this. So we really think it's a matter of time. In the meantime, even though you don't have transparency and actual measurements in a lot of cases, there's some methodologies out there that do estimate the relative environmental impact. Some folks, say you can use cost, the cost per token. That's very transparently available. I think that's an okay proxy, but costs are not actually connected to the energy use. Energy use is something like 2% of the OpEx, depending on the situation. But the cost per token is much more driven by competitive pressures and market dynamics. So you can start to use cost as a proxy, but there are some better proxies out there that use throughput, latency, and some assumptions to estimate. But in short, there are ways to understand. There are ways to choose more appropriate models for the task at hand, rather than always trying to use the sexy frontier LLM, because there is such a widespread. So I'd say model choice is the first one. The second is thinking about the way you're using these models and ensuring that the output tokens are minimized. The output tokens are really are what drive the energy use. And so if there are ways for you to customize the prompt and use specific keywords that actually result in a more concise output, that can reduce impact. And there have been studies out there, 20 to 40%. And then finally, thinking about the data center region. I know it's hard to think about. We're very disconnected, basically, from our physical infrastructure. And when we're behind our keyboard and choosing Scaleway or any other region, it's hard for us to imagine that could actually have a physical impact where it's just a drop-down menu. But different regions have very different environmental profiles, from regions that use a lot of gas, like Northern Virginia, the most popular data center region in the world, to places like France that have a very clean grid. So thinking about the carbon emissions, thinking about the water systems in those regions, and there's a lot of data out there on this. I think kind of starting with those three, the model selection, the prompt optimization, and the deployment region, we can really start the journey towards sustainability.
Thank you so much for all of this advice. And I agree for the region, of course. If we can, at Scaleway, we have several regions. And if we compare, for example, Paris 2 and Varsovie 1, we are very different. Here, two criteria come into play, so the grid, as you said, but also the data center PUE, which is an indicator about the data center efficiency. So basically, it's how much electricity consumed for the cooling system. Not just that, but most of this. In Paris 2, for example, each kilowatt hour you will consume will have an impact of 0.06 kilo CO2 equivalent. And if you're going to Varsovie 1, each kilowatt hour will have an impact of 1 kilo CO2 equivalent. So each kilowatt hours you will consume will have an impact 16 times higher if you're in Varsovie 1 than in Paris 2. So it's the first step to reduce your environmental impacts.
And what's behind that? Are you able to say?
It's the PUE of the data center, because our data center in Paris 2 is much more efficient than one in Varsovie, and also the energy mix. So because in France we have electricity is mainly came from renewable energy and nuclear, which are low carbonate energy, compared to Poland, where the electricity mainly came from coal, which is high carbonate energy. And the second step to reduce your environmental impact at your infrastructure level will be the choice of the products. More the products are managed, more the hardware is shared, and more your impact, lower your impact will be, since it's spread across all users. So, for example, if you switch from bare metal infrastructures to a cube-based infrastructures, you will reduce your impact from 20 to 50%. And if you switch from cube-based infrastructures to serverless infrastructure, you will reduce again your impact from 30 to 50%. So it's a good way to reduce your impact is to use as much as possible managed services to have the hardware of the manufacturing of the servers, which has diluted between users.
And yeah, I'm curious, that's something that's really interesting, and I don't think a lot of people really understand that. Could you speak to why that is? Is it because of more distribution and less underutilization?
Yes, it's for Kubernetes, for example, our Kubernetes product is based on instance products, and instances are on servers. So the impact of the server, if you're using a dedicated server, you will have all the impact of the server. And if you're on instances, you will have just a part of a server, so a part of this impact. And if you're Kubernetes, you have a part of the instance, so a part of the server. So it's working like this. And the last way to reduce your impact will be not oversize your infrastructures, and prefer tool to auto scaling, because if you oversize, more the server are powerful, more the impact will be. It's not always like this, but most of the time is like this. And so be careful not oversize and right-sizing your infrastructures. By doing this, you can reduce your impact from 2 or 3. So it's very important to have the right sizing in your infrastructures. And I have one last question for you. You're working for a huge US company, but we are here in Paris. So do you see an European advantage in AI sustainability?
Yeah, so I've been here for about a year. I was in San Francisco for a number of years before. And it's been interesting kind of on the intersection of AI and sustainability, comparing and contrasting the two locations. In San Francisco, there's a lot of folks interested in the environment and sustainability, and there's a strong, I'd say, industry with that. Then, of course, there's the tech industry, the AI industry. Those things are generally very separate there, that I found. The folks working on different problems. They have different ways of seeing the world, different goals. And when I moved here, I was kind of struck by the fact that divide seems much less here. There's a lot more environmental consciousness, I think, even throughout the folks working on tech, especially on AI. So I think that's one of the sustainability. That's one of the AI advantages of Europe that I don't think gets really talked about. That there is kind of this notion that responsibility is table stakes, and it's a part of how you develop innovation, and it's part and parcel of all of that. So I've been really impressed.
Thank you, and it's very interesting to have your point of view on this subject. So it's the end of this session. So as a conclusion, I think we can say that taking into account the environmental impact of what you build is not just an ethical way to answer to stakeholder expectation. It's also an opportunity to reduce long-term costs, because since the beginning we haven't talked about costs, but most of the time, if you reduce your environmental impact, there is also an impact in the bill, so which is interesting too. And also an opportunity to build a sustainable future. And all in this room, we can all make a small step to all together build this sustainable future.
Yeah, just want to say, when we think about sustainability of AI and the direction where things are going with its energy use, of course we think about the carbon emissions, the water use, and the pollution, but the current trajectory of AI development is unsustainable, not just from an environmental perspective, but also from a financial perspective. What we're seeing energy grids potentially not being able to be compatible with the way things are expanding. So availability in the future of these products, if we continue at this path, might be at risk. And also a big one is the reputational aspect. I really think if things continue at this rate, AI companies, tech companies, data center companies could be seen as the next tobacco and oil companies. And in some circles actually already are seen that way. In the last 18 months, there's been $64 billion worth of data center projects stalled or canceled, a lot in the US, all over the world, due to this perception. And the other day, Satya Nadella said that AI needs social license to operate. So these folks are really seeing that and shifting the development of this technology towards more responsibility, more transparency, and more sustainability is actually critical for its future.
Exactly. Thank you. Thank you so much, Boris. And thank you all for listening. And if you have any question, I invite you to come to us after the session. Thank you.